All right, so this is going to be a very bare bones episode because I don't fully understand how to integrate it just yet. However, I do know how to implement a small delay that's uh, marginally noticeable, but there will be a lot of improvements, and I will make a retraction to this video as well as I know more about the subject matter. Essentially, what we're trying to do, we're trying to have a delay between the switching, so you can see the LED switch from one to the next LED. In due time, I'll be able to do it with more than one, but this is just going to be for one switch. Essentially, what we're doing is we're using timing loops. Essentially, what we have is like a dummy loop, which will do nothing to your circuit except add a delay to it. And the way you can do it is through using these different instruction modes that have different delays. It takes a certain amount of time for your computer to perform these different tasks. The one that I use is NOP because it literally just does nothing, and it delays your code by 1 microsecond. So you would need a million in order to have 1 second. Most I can do right now is 255, but in due time, I'll be able to increase the amount. But in order to do that, essentially bringing up the code, as you can see, we have the code from last time, but I'm going to change it a little bit so that it only has one. It doesn't need even a loop. It just needs to have a delay. So first, what I'm going to do is I found out that if you use CLRA, what it will do, it will clear the value that's stored in accumulator A and give you space in order to fill it again with a different value. So just to clear it out, you do CLRA. So now go back to the logical zero or whatever was stored inside the accumulator A before you put the logical one in there. Um, and then you want to store the new value. For me, I would like to store LSL. Um, I actually don't even need to use the accumulator because I'm not going to be looping. So what I will be doing is just using the LSL and LED1. So that will shift the LED from the first position to the second position. And that's all that we would need to do for this one. However, what we're going to be adding is a delay. So the way that we add a delay is by first clearing the accumulator stored in A, CLRA, and then we can store a new value. The value that I would like to do is first LDAA, and it will be 255 because that's the max number that I've figured out so far. 255. And this is where the loop will start. So we're going to start with loop. And what I want to do is I want to decrease DECA, the value. I would like to decrease the value of the value stored. Hmm. Yeah, the value stored in LDAA by 1. And then I would like to do BNE, which will check to see if it's 0. And if it isn't 0, then I'll loop again and decrease it again. And if it is 0, then I'll skip this part of the code. And that would be the end. That will be an actual. Oh wait, I forgot about this function NOP. Okay, so what will happen is that it loads the value 255 to accumulator A, and then it decreases the accumulator by 1, and then it does nothing, and that will last 1 microsecond. And then it'll check to see if the accumulator A is at 0, and if it's not, then it'll loop again, and it would do the same logic. Um, that will be only for about, I don't really know how long it takes for your computer to do decrement of A, or to check to see if it is 0. But I do know that the NOP is going to be 1 microsecond. So it might be maybe 1 to 4 microseconds, let's say. And that'll be how long it takes for the first loop. And it would take place over 255 times, so it adds up. But for the purposes of our program, what I'm going to do is I don't need to clear A because it's already at 0 after the loop is done. So I'm just going to load the value 255 back into A. 255. And this is why it seems like it's going to be very ineffective. So I need to find better ways to do this. But it loads 255 back in loop A, or accumulator A. And then I need to do another loop, and it'll be loop. Let's call it loop A. for instance. And it's just going to be the same thing as before, but it's just going to add more of a delay. So then it'll be DECA to decrease the value of accumulator A by 1, and then it'll do nothing. It's going to check B and E to see if it's 0, and if it is, then it will continue to the last part of the code, but if it's not, then it'll loop again. And then we have loop, and after that, loop A. After that, then it will shift the logic from the first LED to the second one. So it's going to be 2 rounds of delaying. It's going to do the first one and then the second one, and then it will shift to the left. So what we're going to do, we're going to take 2 LEDs. We're going to have one at pin 0. We're going to have another one at pin 1. LED pin 0, LED pin 1. And ideally, disconnect. Ideally, when I press start, then it will go from the first one to the second one, and you'll be able to see it lit up at number 1 and then go over to number 2. So let's give it a try. And let me just save the file. There you go. And let's give it a shot. Okay, so as you can see, it went from LED 1 to LED 2 rather than just starting at LED 2 or starting at LED 2 because it happened way too quickly. Now, if we added another one, then the delay will be even greater. So let's first reset just to show you that it does it again. It goes from 1 to 2. All right, and let's just take out the loop just to show you that it works. So if you take the loop out, you just do this. As you can see, when we reset, continue, okay, and then we just start. All right, let's give it a shot. Oh, it just crashed on me. All right, you see, THRSim is a very finicky program. Um, there's a lot of chances that it's gonna crash on you through code because it's just very weird at times. But we know how to do this, so it's not that big of a deal to us. We're just gonna initialize the pins again. Press OK. Then we're gonna initialize the second pin, LED 2. Connect, and then there. We're gonna sort it. And what I was trying to prove is that when you take out the code, all this, and you run it, it's just, instead of showing 1 and then 2, it's just going to show 2. As you see, it happened way quickly. Because it's not instant, it's pretty much instant, but it's not. If you added more LEDs, like all the way up to 8, then the jump will be more apparent or more. It will be quicker. You won't even be able to see it. But since it's just a 1, it happened so quick. But as you can see, there was a noticeable difference when we added the delay than when we didn't. So essentially, that's how you add a delay into a 1-switch circuit. In due time, I'm going to make another video where I'm going to do it for more circuits, but that's just slowly adding layers to it. And then the final iteration is where I have a set of 8 LEDs that's going to switch all the way to the 8th one, and then all the way back to the first one. And that will be the end of the project and the first section of my videos.